can exist in three phases: gas, solid, and liquid. What are the relationships? What are the conditions that we can manipulate to convert a particular type of matter from liquid to solid and solid to gas? Okay, so those are the three things we will be looking at in the second learning objective here. And first, talking about the vaporization and condensation there, and that has something to do with the intermolecular forces there. So going from, using water as an example, going from liquid to gas, that's evaporation. Evaporation is an endothermic process. You have to heat up the water. You have to bring in the energy so that water molecule can get from the liquid phase to the gas phase there. Condensation, however, is a reverse process. So in this case, you end up with releasing the energy to the environment, although the release of the energy may not be as obvious as when you apply the heat through a Bunsen burner or burning natural gas or electricity. They're using electricity to heat it up there. Now, liquid vaporization has something to do with acquiring enough energy to break the intermolecular bounds, intermolecular forces there. Okay, so in this case, in order for the liquid to vaporize, you must supply sufficient energy in order to overcome intermolecular forces that hold molecules together in liquid form. And therefore, this is going to be an endothermic process. And breaking intermolecular forces requires energy. In the process of vaporization, you have to supply that energy. Otherwise, without sufficient energy there, and the molecules will just stay in the liquid form. Okay. Now, we do know, though, vaporization happens at any temperature, even at very low temperatures, such as 0 degrees Celsius. It happens at a much slower pace because of the energy requirement there. And there's still, some of the molecules will acquire enough energy to break away from the body of water there. But the higher the temperature, well, the faster that process, because you are supplying more energy there. So if you look at from the molecular point of view, if you have a body of water, you leave it under the sun versus you keep it in the fridge. Under the sun, water molecule will actually evaporate much faster because temperature is higher and there's energy supplied from the sun. So in order for the molecules to escape from the liquid phase into the gas phase, from the liquid phase into the gas phase there, we have to supply that energy there. The higher the temperature, the faster the rate of evaporation. And that, we can understand that based on our everyday life experience there. Okay? Now, if you look at the minimum amount of energy, kinetic energy required for the water molecules to escape, the higher temperature resulting in a higher percentage water molecule to acquire that energy, to get into the gas phase. So the distribution of the thermal energy, the higher the temperature, the higher the thermal energy we have. And remember, we asked you a question in the heat fusion lab. What's the difference between heat and temperature? Well, heat is the transfer of the thermal energy. And temperature is how we measure the amount of energy that we have in there. Okay, so when you have a higher temperature, that means that a higher portion of the molecule will meet the minimum kinetic energy requirement in order to escape into the gas phase there. Okay, so vapor pressure also has something to do. We talked about this in chapter 5, and when we deal with the collection of gases over the surface of water there. So the vapor pressure is something that when you have a liquid, volatile liquid in a closed environment, well, some of that liquid will get into the gas phase. That gas will generate a pressure. That pressure is what we call the vapor pressure. So the pressure exerted by gaseous molecules of a substance that are in equilibrium with the liquid molecules of the same substance. So if you have water, you put water in a bottle there and leave that bottle under the sun. Over time, you will see some water vapor start to form. That vapor, if not escaped into the air, will condense back into water as well. So you reach an equilibrium there. The pressure inside that bottle is what we call the vapor pressure. Okay, so these are the terms that, again, these are the definitions there, how we define these different terms there. And something that, even though you will not be tested on the final exam, but something that you do need to pay attention to. Okay? So the vapor pressure is actually a function of temperature. The higher the temperature, the more liquid will get into the gas phase. The more gas that we have here, the higher pressure. PV equals to nRT, the number of moles, increasing the number of moles, increasing the temperature, the pressure will also increase. So the vapor pressure is a function of temperature. The higher the temperature, the higher the vapor pressure. Okay, so that's something that relates to what we talked about in chapter 5 and under the gas law topics there. Yeah, so again, when we look at the equilibrium vapor pressure of a liquid is seen to increase exponentially as the temperature increases there. So for diethyl ether and ethanol and water there, as you can see the pressure, this is the line. And this is the temperature here. X-axis is the temperature there. Y-axis is the pressure there. As the temperature go up, the pressure is going up. And we're talking about the equilibrium vapor pressure there. And that is when you have a container, a sealed container with certain amount of liquid in there. And when you increase the temperature there, you see an exponential increase in terms of the vapor pressure there. Now, what happens to a liquid when its vapor pressure equals to the external pressure, the air pressure? Well, that's when you do this at home. When you heat up water, water is vaporizing. The vapor pressure of the water, when the vapor pressure of the water equals to the outside pressure, water starts to bubble. Because things are coming out, and things are coming out in the gas form. The water vapor is coming out in the gas form there. So the bubbles that you see there, one can argue, and that's the air dissolved in water, or oxygen dissolved in water. True, that's part of it. But mainly, these bubbles were actually gas-phase liquid, gaseous water, and trying to escape. So the boiling happens when the external pressure equals to, when the external pressure equals to the vapor pressure of the liquid. Now that explains why when you have a bottle of water, when you try to boil it here, it boils at 100 degrees Celsius. Because we are so close to the sea level there. And pressure at the sea level is about 1 atm. And when you have 1 atm, the boiling point for water is around 100 degrees Celsius. When you go to Colorado, much higher elevation, a mile-high city, well, you are 1,600 meters above sea level, the water will boil at a lower temperature. So there, when you're doing the cooking there, you may want to use a pressure cook because water will boil at a lower temperature. You may not get the food fully cooked because of the lower boiling point there. So boiling pressure, the boiling point really depends on the external pressure. When the external pressure equals to the vapor pressure, if the external pressure is lower, then the boiling point is going to be lower. So in a higher elevation place, you will have the lower boiling point of water there. You have to increase that pressure in order to increase the temperature. And the temperature is necessary, a high enough temperature is necessary to fully cook the food there. Okay, so defining boiling point and normal boiling point. Well, a boiling point is just the temperature in which the liquid starts to boil. That is when the vapor pressure equals to the outside external pressure there. But how do we define what we call a normal boiling point? Well, in normal boiling point, you have to specify what pressure we're talking about. So the normal boiling point is when the external pressure equals to 1 atm or 760 millimeters. Okay, so the temperature in which the liquid starts to boil when the external pressure equals 1 atm, that's what we call normal boiling point. So that's a definition, another D word there. And again, as we said, these topics may not appear on the final exam there, but whenever we talk about these definitions there, you need to know